G'day, Mr. Kane here, and we're continuing our journey around the plant cycle, and we're going to look at pollination and fertilization this time. So we'll begin with the pollen, ovules, and the pollination part of it. So back to our friendly flower. Hopefully by now you know all the bits and pieces that are going on inside there. And yeah, we know they come in all sorts of shapes and sizes, and that each one is adapted to a certain kind of pollination. So pollination is getting the pollen from the boy bits to the girl bits, and wind, water, or some kind of beastie will do that, animals or insects or something. So pollination. Here's a little wee thingy showing a pollen travelling from the anther of one flower to the stigma of the next, pollen tubes growing down and getting down into the ovary. So pollen from the anther is caught by the stigma. It somehow, the stigma is sticky, somehow it gets from the anther to the stigma. Wind, water, insect, some of the animal carries it there, and then it grows on down and fertilises the ovary, and you get seeds in the fruit. So we've got insect flowers. Okay, they've got special adaptations, things that they've got to help them. Okay, you've got nectar, smell nice, that sort of attracts insects in there. Brightly coloured petals, they look good, insects want to go there. And the anthers are positioned to rub pollen on the insects. You look at all these anthers here, they're all sort of leaning over, knob on the end, and there's lots of them all here, all clustered around, ready to rub on the back of the insect that is coming in. The pollen's also got little barbies on it to help it hook on to the hair or the fur, if you like, of the insect. And the stigma is all there really sticky to catch the pollen. Here's the stigma here, and you can see these sort of bulgy parts of it. They're all sticky, ready to grab pollen. Wind ones are a bit different. They don't worry about petals or scent or nectaries. Don't need those. They're more concerned with getting the wind to carry the pollen. So the anthers are hanging out into the wind. They've got the really long filaments and a big knobby loose top that flaps about in the breeze so the wind can shake it and the pollen gets blown away. And they're very light, millions and millions of them. In fact, around here when the pine trees and all the shelterbelt hedges are all producing their pollen, you see great clouds of it. It looks like smoke coming out of the head sometimes as the wind catches it at the right time of year. And the stigma are all feathery to catch the pollen on the wind. They're all out there really big and feathery just to make sure they capture that pollen as it's blowing past. Now we've got cross-pollination. The pollen's going from one kind of plant to another of the same kind of plant. Like if it's being travelled by the wind, it could end up on any plant, but they're specialised to only fertilise the same kind of plant. They recognise their own pollen and they kill off other pollen that gets there. Cross-pollination, it goes from one plant to another of the same species, and the other kind of pollination is self-pollination, where the pollen goes from the anthers to the stigma of the same plant. Now, that's not as genetically healthy as cross-pollination, but if cross-pollination doesn't work, it's a useful backup plan to have. They will prevent or try and stop self-pollination. We can do that by having a height difference, so your stigma is way above where your stamens are, so there's a big gap in there so that they can't accidentally bang into each other. And there are flowers that have this arrangement, and then if it doesn't get pollinated by somewhere else, the stigma will actually quietly curl over and capture pollen from its own stamens. Or you can have them maturing at different times. So the anthers are ready in the flower on the left, then after a bit of time, a few days, they wither away and the stigma is mature and ready to receive pollen. And that's our journey through pollination, and now we're going to look at fertilization and seed formation. So fertilization leads to fruit and seeds. So what's happening is the pollen lands in the stigma, the pollen tube will grow down the style, down into the ovule and fertilize the ovule, creating a fertilized seed, and that triggers the ovary wall to develop into the fruit. So fertilization happens when that pollen grain nucleus gets down to the ovule. That's fertilization. Pollination is when the pollen lands on top. That is pollination. What bad writing I've got on this thing. And fertilization is when the pollen grain nucleus, the sperm, if you like, meets the ovule, and that is fertilization. What scruffy writing. Should be a doctor. So that's the difference between pollination and fertilization. So what happens? The fertilized ovules grow into seeds, and the ovary wall grows into the fruit, apples from apple flowers. So all this stuff up here, all this stuff here, dies off, falls off. As soon as this thing is pollination, fertilization happen, it all dies and withers and falls away. What's left? Down the bottom, we've got ovaries, and ovules. We've got ovules, and they will grow into seeds. Okay, ovules grow into seeds. The ovary, this whole sort of arrangement here, will grow up and become the fruit. So all this part here is the wall of the ovary. And you can see up on the top of the apple here, there's those little wee bits there. That is the tips of the sepals left up there. The stalk of the flower is the stalk of the apple. So water leaves the seed, dries out, becomes dormant, goes to sleep, ovary develops into a fruit. So there's a slice of an apple, the seed in the middle there, and the fleshy wall of the ovary. Munch, munch, crunch, crunch, that's your apple. And that's that part of the plant cycle completed. Hope that was informative and helpful. Thanks for watching.